thought we would do more with the Camplux gas water heater boiler thing while we're here and while we've got it. So I thought today we would do the power output test. So have gas boiler, have 15 litres of water in the tank, have the gas bottle down here, ready for gas. We've got the carbon monoxide sensor detector thing. I thought we would stick that in the flue and see what it says. And I've got the thermocouple sensor temperature thermometer thing with a thermocouple probe, one of the long ones. I've poked that in, well, in the top, and we've got the other watery one just poked in the water to see what the temperature output is. So we do the run where we measure the temperature of the water at the start. We do a burn for a defined amount of time, let's say 5 minutes. We then take the temperature of the water then. We can then work out how much energy was required to heat 15 litres of water in the said time. I have a whiteboard somewhere. I should probably write down the temperature of the water before we start. One moment, please. Be quiet. There's a wood pigeon on the roof. Okay, sure, now he's quiet. Okay, anyway. Temperature of the water. Which one of these two temperatures is the water? T2? T2 is the water temperature. 26 degrees. Yep, that would be right. The shop thermometer says it's 20 thingy degrees in here, so 26.4 degrees. 26.1. 26.4 degrees C. And I have measured 15 litres of water and then ran it, and we've still got 15 litres to start with, so 15 litres, or 15 kilograms, because it's water at about 21 degrees. Let me just set this down here for the time being. Water pressure is being supplied this time by the camping pump and the power supply, once I turn it on. Because I was going to do a decibel test, because somebody asked, but then I realised the loudest thing in here is going to be that water pump pumping, and you will not hear this. So we should begin. I will need a timer once again. Okay, have phone with 5-minute timer. Am I ready to begin? No. Let us put the gas on, puff of gas. Let us put the power supply on. Uh-oh, we got a leak. No! Okay, this time with less leaks. Temperature water, gas is on. Batteries in the boiler. Now we just have to, wait, let me sit you here. There's something like that. And we'll get this and the timer at the same time. Although I'll probably go from like when the gas lights in the boiler to, because I can see the gas. And then we'll start it 5 minutes and then we'll stop it. Are you ready? Go. 5 minutes has begun. Should have started this at the start. Yeah, we've got a good 5 minutes to do it. I'll bring you back near the end, or if something interesting happens. Okay, for the first run, an error definitely happened, because the temperature I wrote down of 26.4, I don't know where the thermometer probe was, but it wasn't in the water, because when I turned it on, it got less. And that's not actually possible. We can't get less temperature. So, what we're going to do is scrub that out, and we're going to start again. Scrubbing out 26.4, we are now starting at 27.3. And it's 27.3, and it's already run for 5 minutes. 27.3. And I'm going to turn the water thing up to maximum so the pump's not struggling as hard. So, because I also think we're going to get to the cut off of this before we heat this water up. Anyway, I'm fucking talking. Let's press the button and make it go from gaslit to thingamabob. Here we go, and contact. Go. Okay, this time we are running. Water's pumping. Flow is flowing. 38 degrees output. And currently 92, 93, that's the flue temperature output. And we'll have a carbon monoxide reading, shall we? Of near the flue. Let's go directly above it. 8, 9, 10, 13, 15, 20. 32. I mean, there's enough there to kill you, but it's not like hundreds or thousands at a go. Oh, that's better. The temperature's going up now as I was expect. That's better. That makes more sense. Anyway, I'll bring you back once it's done. 40 degrees. 40 degrees. Okay, I should have said it. That was on the minimum gas settings and maximum water flow. So that should be like the minimum output of the shower. So now we're going to set the gas to maximum gas and minimum water flow. And that should get us the actual maximum heat transfer in the water. And we'll get the maximum reading, which I will now run. And I will bring you back once I've done all that. Okay, I have run the test. Alright, I've run several tests. Okay, I need help with you folks to make this make sense to me, please. Well, either that or somebody's lying somewhere. Where am I going to put my phone? Somebody won't drop in the water because it's hot. Right, is that actually in shot mostly? Mostly in shot. Yeah, we'll bring it down a bit. Okay, first run. Okay, so we've always got 15 litres of water. The water in the tank hasn't changed. It's always 15 litres. Okay, 15 litres of water. Started at 27.3, ran for 5 minutes, finished at 40. And that was with the gas at minimum and the water at max flow. Max flow. Minimum gas, maximum water. I got a calculation of 3 kilowatts. 3 kilowatts, okay. So I then ran the test again, and I did maximum gas and minimum water, and I only ran it for 2.5 minutes because it was getting the water temperature and the output of the shower was 75 degrees. I was kind of not sure if it was going to cut out on me because I didn't want it boiling in there. So let's say I ran that one for 2.5 minutes. That gave me a calculation of 9.5 kilowatts. So maximum gas, minimum water, 9.5 kilowatts. And I thought that was not quite the 20 kilowatts that it's supposed to be. So I then ran it again. No, wait, what did I say? That was max gas, minimum water. So then I ran max gas, maximum water, started at 30, finished at 47, and that was for 2 minutes. Yes, I'm aware the time is changing, but the time changing doesn't matter as long as there is a period of time we've measured. 30.6 to 47 in 2 minutes gave me 8.4 kilowatts on max and max. Now, so yeah, those calculations that we just did on the whiteboard, that assumes 100% efficiency. Just managed to close all the tabs. Well done, idiot. Yeah, so the 90% efficiency that claims everything drops down to, instead of it being 9.5, it's 8.4 kilowatts, etc. But that is somewhat of a disparity between the 20 kilowatts that it says on the label on the side. So yeah, give us your thoughts in the comments about that calculation. And now what I thought we would do was we'll take this cover off it and then point the thermal imager at it and film it as it runs. Let's do that. Right, let's have a look at it running without the cover on. I have taken the liberty of spray painting it matte black so the thermal imaging works. As we've got the thermal imaging camera, we will film it here. In the previous video, do you see this micro switch? This micro switch here. That micro switch there. That one that goes onto the water body. It is absolutely activated by the water pressure itself. Now, let me see if I can... Right, you stay there while I put the gas on. Gas. I'm going to put the gas on. Right, so gas. So it should now light when I activate the suppose I'm going to start filming video as well while I was doing it. See, there's the switch moving. There's the gas burner burning. There's a thermocouple over there. And hopefully now I can zoom out without button mashing again. Withdraw. Withdraw. Okay, there we are. Gas burner burning. See all the little gas nozzles in there? And hopefully the FLIR's recording and hasn't crashed again. Kind of looks like it's crashed again. Appears to not be changing in temperature in any way, shape or form. Has it crashed? Yeah, it's totally crashed. Great. Right. Okay, I'm going to try filming this again. That camera's still running. The FLIR's running. Got the hotspot, hotting. Right, and go! Gas, 1,000,000 degrees. Oh wait, I've got it set to 150 now. At least you can see the change in temperature. Right, so that's not going to work for us because we need more than... Oh wait, I can move the hotspot out of range. So let's move the gas out the way. Out you go. Hop, 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 hop. Hotspot. That's better. Right, now we should be able to see the gas coming out. Oh, it vents out the sides. Nice, you can actually see it venting out the sides. Yep, it's sure in there. So like I say, the hottest bit is still this, the burn chamber bit where all the magic happens in there. That's where the main heat exchanger is. Right, let's take the FLIR out and wander around about it. So we should be able to go in there. Right, so that's well over our hottest spot, so let's see if we can change the temperature range. How hot's my water? It's pretty hot. I'll look in the shower head. It's a lot of action. How's my pump doing? Yeah, it's pretty warm as well. Power supply's okay then. Okay. Well, as we saw, right, so the micro switch is definitely the pressure control. So that's, micro switch is the pressure control. The other sensor on the hot outlet is definitely just a hot out to display because it's not even plugged in and it doesn't care. So the gas burner's burnering. And we saw the outlet of the burn chamber. That was definitely venting out the sides and out the top. Perhaps with a chimney it would draw in, but not with the way those vents are angled. Hey, I don't know, maybe it would draw more if it had its actual chimney head on it. Now, I'd like to put the outside cover on and point the thermal imager at it, but being just white paint, you know, shiny white reflective paint, it's not going to really show us much in the way of temperature. We would just get reflections from other things. Granted, I could paint it matte black, but the next person I give it to might not like that as much if I painted it black. If there's any other options you can think of to put on the outside of the case so we can get temperature, maybe Captain Tape. If I can get more Captain Tape, maybe I could wrap the outside of the case in Captain Tape and then we'll get a thermal reading that way. What have we learned today? Either I'm bad at maths or I don't know how they're getting the 20 kilowatt. What am I doing wrong? I mean, like 20 kilowatt seems like a number that could be achievable. I mean, you could certainly get the 20 kilowatt burners, not hard to do, but if we're only getting 10 kilowatts in the shower, that's definitely not 90% efficiency. Where are my maths going wrong? I mean, I'm fairly confident there's 15 litres in my tank. We had marked it previously for other experiments. I mean, 10 kilowatt is still a domestic hot water shower, an electric domestic hot water shower. It's absolutely able to keep up with a supply of cold water and output hot showering water. I'm not taking that away from the shower. The shower absolutely fucking works. It does the showery thing. It increases the temperature by your requirement for a shower, but it just doesn't do the numbers that it's supposed to. And I'm kind of, I want to know why. That's what I want to know. So in the comments, I want to know why. What am I doing wrong? What's wrong with my test? How can I test it better? And how can I make it right? And how can I be sure that I'm right? That's what I want you guys to help with. So leave that down in the comments below. We've had a look through the thermal imaging, just because we can, just to see what the heat exchanger looks like with all the pipes and swirly bits and the gas burners and all that. And that was interesting. So comment down below, how can I make my experiment better and how can I make sure my numbers are correct for my test? And any other comments, questions or tests you'd like to see with the Camplux gas-powered shower thing, leave them down below as well, and we'll do more tests, or at least tests that I can do here in the workshop. As always, thanks for watching.